Okay, number 8. So it says solve by method of your choice, and I have 8x minus 4y equals 12, and I have 3x plus y equals 17. Okay, so I'm going to choose to solve this by substitution. We're going to subtract 3x from both sides, and I'll get y equals negative 3x plus 17. Recall, to solve by substitution, you first of all need to get one variable all alone so that you can take the expression that equals the variable and put it into the other equation. So when I do that, I get 8x minus 4 times negative 3x plus 17. Distribute here, equals 12. 8x, negative 4 times negative 3x is positive 12x. Negative 4 times positive 17 is negative 68 equals 12. So 8x plus 12x is 20x. Add 68 to both sides, and you get 80. Divide by 20 on both sides, and you're going to get x equals 4. Okay, what do we do with this x equals 4? You're going to put it into the original equation, and you're going to find out what your y is. Okay, so we're going to put this into the original equation, and I get up here 8 times 4 minus 4y equals 12. It doesn't matter which equation, by the way, you put it into. I just chose the top one because it was the top one. 32 minus 4y equals 12. Subtract 32. Negative 4y equals negative 20. Divide by negative 4. Y is going to be 5. So my ordered pair is 4, 5. Now, it would not be complete if you didn't double check and make sure it works for here. So I'm going to do that. 3 times 4 plus 5 equals 17. This is 12 plus 5 equals 17. And yes, absolutely, that works. So you always want to check it. I'm going to check the other one. 8 times 4 minus 4 times 5 equals 12. That's going to be 48, or excuse me, 32 minus 20 equals 12. And yes, that works. So you always want to check your work. All right, so number 9. Solve a method of your choice. So this one, just to give you a different method to see, I'm going to go ahead and use it for elimination. So for elimination, you need to have something here and something here that are opposite. So nothing is really sticking out that is going to be easy to work with as far as one that just is opposite automatically. So what I'm going to do is I'm going to make them opposites. We're going to force them to be opposites. So I'm going to look, and I'll just look at, it's very simple, 5 and 2. If I multiply this one by 5 and this one by negative 2, then that's going to be negative 10. That's going to be positive 10, and therefore we have them opposite. So I'm going to multiply, though, everything in the equation by negative 2 on the top equation and everything on the bottom equation by 5. So here we go. I'm going to write out here what we get. So the top equation is going to get negative 10x minus 20y equals negative 30. I just multiplied again the top equation by negative 2. The bottom equation, I'm multiplying everything by 5, and I'm getting 10x plus 20y equals 30. Well, something really interesting happens here, because when I add everything together, you obviously see they're completely opposites to each other, and you end up getting 0 equals 0. Well, let me ask you, when does 0 equal 0? Always. So that's why there are infinitely many solutions, and really this is what it means. The top equation, that's the line. Guess what the bottom equation looks like? Just like that. It's the same line, and so that's why a solution in equations is where they touch. Well, where do they touch? Everywhere. So that's why it's infinitely many solutions. Okay, let's go ahead on to number 10. Use the given conditions to write a system of equations. Solve the systems to find the numbers. All right, the sum of two numbers is 7. So I'm going to let one number be x and one number be y, and that's going to equal 7 because it says the sum of two numbers is 7. Now it says if one number is subtracted from the other, so x minus y, the result's going to be 3. Okay, so now it wants you to solve. So all it was wanting me to do is set it up, and now I'm going to solve it. So I have x plus y equals 7 and x minus y equals 3. I'm going to solve this with elimination. The reason I'm going to solve it with elimination is because remember what we were looking, the goal of elimination is to have them be opposite. And look at this. Positive y and negative y are opposite. So when I add these two equations together, something wonderful mathematically is going to happen. I'm going to have a 1x plus a 1x, and I get a 2x. And the reason it's wonderful is because those cancel out. 1y minus 1y is going to be 0, and 7 plus 3 is going to be 10. So divide by 2, and I'm going to get x equals 5. Okay, what do we do with that? Put it back into the original equation, and I get 5 plus y equals 7. Obviously, that's going to be 2. 5 plus 2 is 7, so y is going to be 2. Again, check yourself before you wreck yourself. So that's going to, if I plug this back in, it's obviously going to be 5 minus 2 is going to be 3. 5 minus 2 equals 3. So that one works out just fine. So the answer is 5, 2. Okay, number 11. Graph these. So I have y equals negative 2x minus 4. So y equals, this is the mx plus b. This is my b at negative 4. B is my y-intercept. Y-intercept, so I go down to negative 4 and put a dot. My slope is negative 2 over 1. So that means down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1, and so forth and so on. I'm going to use my handy dandy piece of scrap paper here to draw my line. Now, notice here, if we notice here, this is not a equal to, it's just a greater than or a less than sign is a dotted line, meaning it doesn't touch it, it just approaches it and gets very close to it. So I'm just going to do my dotted line here. And it says that it's greater than the line. So everything on the higher side of the line where all of the y's are bigger. So all the bigger y's, you notice on the y-axis, this is negative 4, all the bigger y's are over here on this side. The smaller y's are on this side of it. So I'm just going to do this and say, okay, it's all of this area. This is every single ordered pair in this shaded area is a solution to that inequality. Okay, so now we have to do the other one. The other one, again, start with my b. My b is my y-intercept again. And I start here at negative 7. Negative 7's right here. Now my slope is now, nothing's in front of the x, so that means a 1 over 1. You always can put a 1 next to a number because 1 times that number is just what that number equals. So it's up 1 to the right 1. Up 1 to the right 1. It's hard to see these little tiny checks. Let me get that right. Up 1 to the right 1. There we go. 1 to the right 1. Okay, and I'm going to use my scrap piece of paper again to draw my dotted line again, because if you notice, it is not a less than or equal to or a greater than or equal to. And it says less than. So I'm looking for all the y's that are less than, and I look at all my y's down here are less than. So that is going to be all of these down here. So the solution to my system of inequalities, systems means two or more, is just where they overlap, which is all of this red shaded area. Okay, that's kind of fun. And here's a prettier, you can see this here, just zoom in on that. Second, you can see that's a little bit prettier than mine. Okay, getting near the end, number 12. Binomial theorem. We're going to use the binomial theorem to expand and result in simplified form. All right, so to use my binomial theorem, you can do a couple things. You can use your Pascal's triangle, and you can go ahead and use your sixth row, which I'll show you. Remember how to write that out. So let's go ahead and write it out. And I get 1, 1, 1, 1, 2, 1. You see what I'm doing is that these 1 plus 1 is 2. So then we're going to always start with 1. 1 plus 2 is 3. 2 plus 1 is 3. And 1. 1 again. 1 plus 3 is 4. 6. 4. 1. So I have, and we need it, I need to the fifth, so I need 1, 2, 3, 4, 5. I need one more, because it's always 1. Here is 5. Here is 10. Here is 10. And here is 5. And then one more at the end, 1. So this here is what I'm looking for. All right. Now, if you remember for this, then I would be, I'm going to write 1, 5, just going to leave some space here, 10, 10, 5, 1. Okay, so you take your first expression, and that's going to be to the fifth power. So that's 1 times 2x to the 5. And then my y is going to be to the 0 power, which is essentially 1. So I'm just going to leave it out. plus, we're going to have our 2x now to the 4th power, and then my y, so I have a negative y to the 1 power, plus, sorry, it's a little crammed, 2x to the 3rd power and negative y to the 2nd power, plus 2x go down to the 2nd power and negative y to the 3rd power, plus 2x to the 1st power and negative y to the 4th power, plus, and finally we're at 2x to the 0 power. 2x to the 0 power is 1, so we're going to leave that out. And we're just going to put negative y to the 5th power. Okay, if we just simplify all of this, this is what we end up getting. 2x to the 5th power is 2 to the 5th power, which is 32. So here's the final answer down here. This final answer is right here. And all we did to get this is, again, I'll just talk you through it. 2x to the 5th power is 2 to the 5th power, which is 32. X to the 5th power, which is 5. X to the 5th, excuse me. This, the way we got 80 was here. 2 to the 4th power is 2 times 2 is 4 times 2 is 8 times 2 is 16. And then we multiply that times 5, and that's 80. 5 times 16 is 80. And then the negative came in here, where the negative y. So that's where the 80 came from. The next 80 is similar, but not quite the same. So 2 to the 3rd power, which is 2 times 2 is 4, times 2 is 8, times 10, which gets you 80. And then this is a negative y squared, and that gets rid of the negative. So that's where that comes from. Same thing here. We have 2 squared, which is 40, or excuse me, 4 times 10, which is 40. And the negative now is an odd power, so it stays a negative. 5 times 2 is 10. And then negative 1 to the 5th. So that's how you do it as far as when you use the Pascal's triangle. You can also work it out, which I can show you also later on in the video, without doing the expansion. All right, find the 3rd term of the binomial of 2x to the 7th power. Okay, because I've already got this binomial expansion out and we've got it, you know, to the 7th, this was to the 5th, I only need 2 more rows, so I'm just going to go ahead and keep expanding. Now, I'm out of room on here, so I need to get a little bit more room. Get some room here. So I have, my next one would be 1, 6, 15, 20, 15, 6, and 1. And the last, or the one that we're interested in, is 1, 7, 21, 35, 35, 21, 7, and 1. All right, I don't even need the rest of that because what I'm looking for is the 3rd term. The 3rd term is 1, 2, 3. So that's what I need, is the 21. So this is just going to be 21. And it's this one, the 3rd term. So the 1st term is going to be 2x to the 7th. The 2nd term is going to be 2x to the 6th. And the 3rd term is going to be 2x to the 5th. The y is going to be, the 1st term is going to be y to the 0. The 2nd term is y to the 1. And the 3rd term is y squared. All right, and so if I go ahead and do the math out, I get 672x to the 5th, y to the 2nd. Again, you can use your y choose k on this, but it is easier. I mean, it's simpler if you spread it out, or if you like the y choose k or the n choose k formulas that the book shows, you can absolutely use that.